Kangerlussaarmi issuppisoqaassusaa qano issusaa silaannamillu aniasitsinarani carbon annertussusaa qanorsunnerpa.
In soil, there are many layers and many characteristics that define each layer. Many factors affect the soil and cause it to differ layer to layer. A few of these factors include the type of vegetation that grows on the surface and the age of the soil. Our group was interested in studying how these specific factors influence the carbon content and respiration of Arctic soil.
We hypothesize that carbon content, respiration, and moisture of the active layer will differ depending on soil age, type of vegetation, and the layer of the soil.
We chose these 3 spots because of their different ages. Kellyville, the oldest soil, is approximately 8,500 years old. Sugarloaf soil is 7,300 years old, and Russell Glacier, the youngest soil, is 6,800 years old. These 3 spots, we hoped, would give us an idea into how age affected soil.
At our 3 spots, we dug down to the permafrost in order to see the different layers in the soil. Here we saw an organic layer, 2 to 3 other active layers, and the permafrost layer. We took some test samples from the soil which would be analyzed in the lab later on. We also drilled up a core of the permafrost. In order to figure out the amount of the CO2, we used a LICOR. The LICOR measured the CO2 released over a period of time, and we used that data to determine a flux or rate at which the soil respiration occurs.
We took a sample from each layer in every pit that we dug. We put those into dishes and weighed the samples, then put them into a dry oven to measure how much water each one contains. After the soil was dried, we burned the samples to measure the amount of carbon each one contained.
The data we collected showed us that the organic carbon content in the soil samples was higher in areas of high vegetation and increased slightly as soil age increased for both vegetation types. We also found a positive correlation between the water and content of the soil and the organic carbon content.
Our hypothesis was that measurements of carbon content, respiration, and moisture would be different between the varying soil ages and vegetation types. Based on our analysis, we can confirm our hypothesis. We found that the further away from the ice the soil is, the more moisture there will be, and that the more moisture there is, the higher content of organic carbon.
In the future, scientists predict that Kangerlussuaq will receive more precipitation due to climate change. Usually that will lead to more productive soil and increase in the growth of organic material. However, higher temperatures and moisture is also likely to lead to an increased rate of decomposition of organic material. If organic material is decomposed faster than it's being produced, the quality of the soil could decline rapidly. In order to have a better understanding of the effects of the climate change on the soil in the Kangerlussuaq area, further data collection and analysis is needed.